Hello students, this is the video on how to answer the question, video help, how to answer the question date assignment 3. I'm going to share my screen. And I'm looking off over here because the screen is over here and the camera's here. So I'm going to be looking away from you at times and may bother you. I hope not. So we have, I'm going to talk first about main effects. So you're asked about main effects and interactions, and this is the case, will also be the case with the new data set and new, more robust interactions data assignment 4, but it kind of worked the same way. So we have 3 different things. We don't care about the intercept in this case, rarely do. There are some times when we might, but we don't in this case. We have gender as an independent variable. We have keyword as an independent variable with 3 different keywords. And then we have an interaction as a keyword. And in this case, all 3 are significant at 0.000. Let's talk about main effects first. I'm going to go to this example. So in this particular example, I've got some times when we give out a coupon, and there are times when we have ads. And there are times when we have no ads and no coupon, times when we have no coupon and an ad, times when we have a coupon and no ad, and then finally we have a coupon and an ad. Now, for the main effects, what you're going to look at, first of all, for the main effect of ads, which is the 2 lines, which line is higher? So it's sales per week. As we go up, we get more sales, and one of these lines is bigger than the other, and I'll give you like 3 seconds to figure it out. The line with ads is higher than the line with no ads, and in our case, it's going to be color-coded, so it'll be a red line, a blue line, and if ads is a red line and it's up here, and no ads is a blue line that's down here, the main effect is that having an ad leads to higher sales. Now, what about the coupon? So for the coupon, we set the coupon on the horizontal axis, and we have a coupon here and no coupon here. So what we're going to be doing is we're going to be comparing the midpoint here, in particular if we have an even number in our data set of ad, no ad, and coupon and no coupon. This midpoint here is our level of sales that we expect when we don't have a coupon, averaged over the holding constant for averaging for ads and no ads. This over here, the level we would expect to have when we do have a coupon is the average of these 2 points. We do have a coupon, so we do have sales. Now there are cases where, and in this particular case, we would say that because we designated no coupon is 0 and coupon is 0, that having a coupon has a positive effect on sales. Having ads is no ads is 0 and ads is 1, that having ads has a positive effect on sales versus not having ads in terms of sales. So here's an example where you have a coupon and no coupon, and there's a click required. So they have to click on the email and kind of go into there, as opposed to being sent the email and sent the ad code in the email itself. And we can see that having the average of having a coupon is better than the average of having a no coupon, like this to this. Now, in terms of which one works better, not having a click, like sending the coupon in the ad, is better than having a click, requiring a click. And so in both those cases, we can see that no clicking is better than clicking, and having a coupon is better than not having a coupon. Now, if we look at our own data, our own output, here, we can see that there is a difference between the blue line and the red line. In this case, the red line is male and the green line is female. And you have to figure out which one of these on average, either this point, or this point, is higher. And because we already know from the output that gender is significant, means that there is a difference in terms of generating revenue between males and females. And some of y'all already remember from data assignment 1 kind of the nature of that. And we can look on this output and see, and you've got to determine whether the blue line is higher on average than the green line. And then we also see that keyword is significant. So you look at whether it's significant or not, and then you tell me the nature of the relationship. In this particular case, the average of one of these 3 keywords is higher. Either this, or this is higher. And you also have to tell me whether the blue line's higher than the green line. Not that complicated. Not that complicated. I'll get to the interactions in a minute, but I think that gets you through the main effects. So you have to do the main effects and the interaction. Main effect, gender is significant. Main effect, keyword is significant. Now, gender times keyword refers to the interaction. It is significant. When we get to data assignment 4, you'll see some more robust interactions. Let me describe a few interactions for you. Okay, in this particular situation, we have an interaction between what it's showing me there is I used the bad word, the worst one you can think of in the last take of this, and I had to stop it, and I'm going to have it let me know my video's ready. I got to make sure to delete it, not post it. So anyway, here we have demand for flights to Chicago. Now, the main effect of price on quantity demand is negative. As we raise the price from $100 to $400, we get a big drop-off in demand here and a smaller drop-off in demand here. And D1 indicates leisure travelers, and D2 is business travelers. And the main difference between these two functions is that the slope is much steeper here in absolute value terms. The much steeper pitch to that in absolute value terms, the D1 versus the D2. And we would say, in words, that leisure travelers are more price sensitive. Business travelers are much less price sensitive, and they have a whole set of complex types of things that they do to try to get the business traveler to pay a premium price and then to go ahead and fill the rest of the seats up with us price sensitive leisure travelers. They're a whole complicated set. So this is an example of interaction between a continuous variable and then a nominal variable where we've designated leisure travelers as 1s and the business travelers as 2. Another type of interaction would be a crossing interaction, where in this particular case, they probably have, and it's actually an example I use for class, so it's not something that's generated from an actual SPSS output or an actual statistical package output, but there will probably be no main effect of this. The average here and the average here is not much different. If it was, maybe slightly in overall increasing thrillingness. D1 are families with young children, and D2 are youths. In the movie My Cousin Vinny, youths, but youth, the youth of America, which I think I define like 11 to 17. Or something like that, 10 to 16, something like that. For the youth target market, demand goes way up as thrillingness improves. For families with young children, it goes down. It goes up to a certain point, but then it starts going down. Another example of a situation where we have like a crossing interaction, and the main effect of these kind of things, this is an example of selling cell phones, or some other piece of equipment, and it has to do with simplicity. So the two things, high functionality versus simplified. And then we have two groups. We have people under 35 and people over 35. So high functioning really works for the under 35 crowd. And simplicity they don't want simplicity. They want high functioning. The older people, the greater than 55 crowd, they like to have more simplified, and high functioning doesn't do that much for them. So this is a situation where if you're just comparing these two, you probably have no main effect of functionality, and because the two groups demographically is about an equal number of people, not much difference between I don't know, I guess I would probably have to say high functioning is a little bit better, a little bit more, maybe a main effect where high functioning is better than simplified, but probably no effect of age. We might, in this case, depending on how much data we had, how many data points we have a situation that had no main effects, but you did have an interaction. This is crossing or crossing or inverse moderation, I call this. So in our output and answering the questions for, question one, what does it tell us in main effects? We've got to figure out there's a certain type of synergy here that happens between a particular gender and a particular type of keyword that we use to target people in our Twitter campaign, which is where this data comes from. And so you've got to find that thing. Now, the regressions are the next things that we did. So when we run the regression, we're in a similar situation, although we're not looking at interactions, only looking at main effect. We looked first, and I think the way I have this set up, you should look at the last box in each group. Look at the last box in each group. So the significance, and this is in ANOVA, analysis of variance, ANOVA, it's significance of F, and in regression, it's significance of T. We ran, the other thing I want to point out is that we did this in logistic regression. If you do not have logistic regression, you can run it as ordinary regression, and you'll get virtually the same output. The beta will have the same signs. The numbers might be different, but you'll have the same signs, and it'll all come out the same. So if you've got like a student version, or you've got IBM 23 or version 23 or 24 or something, and you do not have logistic regression, it's okay. You don't have to have it. So the outcome in this case, and I'm a little bit ahead of myself because I need to go to the first one first. This case is converted. So the dependent variable, the output variable, is where they converted or not. It's important for doing question 7, to understand what converted means. So in this particular case, a 0 means they did not install and play the game. A 1 means they did install and play the game. Not installed and played, did install and play. Because remember, in regression 7, we actually selected out or selected in the people who had converted, who had played the game at least one time, and we looked at a subset of that data. And that'll give you a clue as to how to answer question 8 as well. So in this particular case, whether or not they installed or opened the game, and we have keyword is significant, video is significant. Now then we have to look at the nature of the relationship. So once we know that it's significant, we have to look at the nature of the relationship, and that's captured in the beta coefficient. You may remember, maybe, no, probably not, 9th grade, you're drawing graphs on graph paper for Algebra 1, and they tell you that the slope of the function, y equals mx plus b. Now, in this case, it's alpha equals beta x plus e. Y equals alpha plus beta x plus some error component. Geez, I could get in real trouble. They put this on YouTube, and I could get in real trouble if I mess that up. But in high school, Algebra 1, y equals mx plus b. Well, the m was the slope. In this case, a beta is the slope. So what the slope means is for every 1 unit increase in x, what happens to y? How much does y go up or down? A negative coefficient means that as we go up 1 unit in x, the propensity to convert goes down. Significantly goes down. If we go here to keyword Clash of Clans, for every 1 unit increase in x, the propensity to convert goes down. Now, in order to understand what these 3 variables mean, we have to remember how we did the coding. So we coded males as 1 and females as 2. It's an arbitrary thing. We just as easily said, females are 1, males are 2. And then all of this would have been exactly the same, except that beta coefficient would now be positive. Exactly the same. Standard error, walled stat, degrees of freedom, exponent of B, significance of T, all the same, just positive if we recoded it. But we coded it as males 1 and females 2. So that means that as we go from 1 to 2, from male to female, propensity to convert goes down. And then you also have to go through that same process to explain how keyword Clash of Clans affects the propensity to convert, and how using video content affects the propensity to convert. Now, engagement rate is a more natural variable. It's a metric variable. We have some level of engagement with the content, the Twitter content. And if they, the more engagement there was in this case, so engagement rate and propensity to convert covary in a positive direction. So for every 1 unit increase in engagement rate, we get a propensity to convert increase of 3.79. And the higher which means they covary in the same direction. It's a positive relationship, meaning the higher the engagement rate, the higher their propensity to convert. Now, if we go on to the next one where we put premium in as the outcome variable, we get fairly similar results. So the explanation here is similar to the explanation here. The only difference is that all of a sudden, in terms of become a premium player, the engagement rate is negatively related to the propensity to become a premium player. And that's not what we would expect. And it happens again when we look at the effect between the engagement rate and revenue. It's negative. That's not what we expect. That's a counterintuitive finding. Get a bonus if you can figure that out. So if you can give me, you don't have to actually know the actual answer. I have a theory. Now, the data doesn't tell me whether my theory is right. I just have a theory for why that's the case. You don't have to have the same theory as mine. You have something completely different. Reasonable theory as to why this is the case. And for the difference between like a 96 and 100. I might have said extra credit. I didn't really mean that. Difference between a 96 and 100 is if you can explain this negative relationship here and here with revenue. So along the way there, you have to answer a couple questions like, we recoded several of the variables. Why do we do that? Just a hint, we wanted to focus on some specific thing in these different categories, like the type of content or the type of keyword or something like that. We want to compare, focus on one specific thing. In question 4, you might find something else you can do. And then that idea you come up with in 4 for focusing on one particular thing, you might be able to use that again in question 8, where you have to do kind of your own analyses. Okay, so in the regression that we use for question 7, we went in and we did something a little bit different. We went in and we filtered out. We did, and this is called compute if. And compute if is it compute if? It's not compute if. So in this particular case, I think SPSS, they would call this a filter. And we filtered out in this particular case some of the people in the data set, some of the data points. And we focused on this particular set of data points where converted equals 1. So that's kind of the opening part of question 7, and some reasonable explanation for why we might want to do that. And then if you can do that, make that reasonable explanation for why we might want to look at just the people who were converted equals 1, then that might help you with question 8 as well. So if you can do that, that'll help you with question 8, where you kind of have to do your own analyses. So now we're running a regression with a subset of the data. We use revenue as the outcome variable. And you see that we actually have now, with revenue as the outcome variable on this particular subset of the data, one of the variables is not significantly related to revenue. So the content video, not related to revenue, we don't have to talk about it anymore. You tell me it's not significant, not related. The data say content video is not related to revenue with this cut down version of the data, and you're done. You don't have to talk about it anymore. We do have, again, two positive relationships. Gender and the type of keyword we used is related. Once again, you have to look at the beta coefficient. Negative beta coefficient means as we go up in X, we go down in Y. So if we go from 1 to 2, males to females, then we get less revenue. And so that's how you have to explain that. And you have to do the same thing for content video. For question 8, you do not have to run a regression. You could do something similar to this selective. It's called amongst the statistician community selective, not computive, selective. All of a sudden, you know, when you're on these videos, and this is already my third take. I told you about the bad word I used last time. Selective, and you might be some sort of selective. You might want to look at another subset of the data. You might want to look at, and then you can run descriptives, crosstabs, that kind of thing, or frequencies. You know, you can do some sort of qualitative type of thing where you're just looking at frequencies and crosstabs, and you do not necessarily have to run another regression or another ANOVA, and then you explain kind of the results of that. So kind of question 8 separates the wheat from the chaff, the A's from the B's, and this assignment, and then your ability to come up with a reasonable explanation for, you know, these counterintuitive findings is the other thing that will set you up for like an A+ instead of an A. That's it. I'm going to stop sharing and stop recording. Good luck before I stop.